Good morning, children. Today I am starting electromagnetism. Now, in electromagnetism chapter, you will learn the relation between the electricity and magnetism, how they are interrelated. And that concept first introduced by physicist Ørsted by performing his famous experiment, which is also known after his name, Ørsted's experiment. First of all, I will discuss the setup, observation, and then last, what are the conclusion made from the experiment. So, how the experiment performed by Ørsted? First of all, a current carrying conductor AB is taken. Okay, a current carrying conductor AB is taken, and suppose it is connected to a battery, rheostat and key. All are connected in series. So when the key is closed, then what will happen? You see, the current will flow from A to B according to the battery connection. And what Ørsted did, a magnetic needle is kept below the conductor, which is parallel to the direction of the current. Okay, direction of the straight conductor. You see, this is the straight conductor and needle is kept. It is parallel. What is observed? The moment current passes through the conductor, the north pole deflects in the inward direction. Means if this is the north pole, it is deflecting like this. It is deflecting like this. Okay? Means it is deflecting in the inward direction. Alright. Now what important conclusion Ørsted made from this experiment? That whenever current passes through a conductor, a magnetic field is produced surrounding the conductor. This effect is known as magnetic effect of current. So directly you may get the question, what is magnetic effect of current? So you please note down, I am telling it slowly and please learn and remember. What is magnetic effect of current? When current passes through a conductor, surrounding the conductor, a magnetic field is produced. Please follow the words I am saying. Surrounding the conductor, magnetic field is produced. This is known as magnetic effect of current. Ørsted demonstrated what will be the direction of the magnetic field produced due to the current, but he was unable to say how much magnetic field, means what will be the magnitude of the magnetic field produced. That was given by another two scientists, Biot and another one, Laplace, that they gave us in the form of laws, but that you will learn in the higher classes. So now you will just concentrate that in Ørsted experiment, how to find out the direction of the magnetic field. Alright, here you see the current is sent from A to B, that is left to right, and the needle is kept below the conductor. Now, it is not mandatory that you have to do this. One can send the current from B to A. One can keep the needle above the conductor also. Alright, in that case also, what you will observe, the moment the current passes through the conductor, the needle deflects. The deflection of the needle depends on the direction of the current. And how we can determine? By using right hand palm rule. This right hand palm rule is not given in your book, but right hand palm rule, it is very easy to apply and you can find out easily the direction of deflection of the needle. That's why I am just teaching you. So what is my right hand palm rule? You keep your right hand palm along the conductor in such a manner that these four fingers, they are along the direction of the magnetic field and the palm is facing the needle. Then the thumb will give you the direction of deflection of the needle. Alright, now here as the thumb is away from you, so you cannot see it. So I am just showing you it in opposite direction. Suppose the needle you have kept in the upward, means above the conductor you have kept. You see, then how you will use the right hand palm rule? As I said, set your right hand palm in such a manner, four fingers along the direction of the current, palm facing the needle. Then you see thumb will give you the direction of deflection. So how the thumb is moving like this? So you see the north pole, it will move in the outward direction. How the thumb is moving? Like this. So you see it is moving in the outward direction. Alright. So this is the way, by using right hand palm one can find out what will be the direction of the magnetic field. Another rule is there, by using you can find out what is the direction of the magnetic field, that is right hand thumb rule, T-H-U-M-B, thumb, right hand thumb rule. The rule just now I said, that is right hand palm rule, P-A-L-M, right hand palm rule. Now this one is right hand thumb rule. What is right hand thumb rule? Suppose there is a current carrying conductor. You grasp the conductor by your right hand 4 fingers. So you see this is the conductor and this is the direction of the current. This tip is the direction of the current. How I will hold it? Like this. How? The thumb is along the direction of the current and you are holding it by 4 fingers. Then you see the direction of the 4 fingers will give you the direction of the magnetic field. Means here you see what is the direction of the 4 fingers. If I hold it like this, in the anti-clockwise direction. So what is the direction of the magnetic field? In the anti-clockwise direction. Alright, so from Oersted experiment, first thing what we can get, the concept of magnetic effect of current. What is magnetic effect of current? When current passes through a conductor, surrounding the conductor a magnetic field is produced. Then secondly, the direction of the magnetic field depends on the direction of the current. If the direction of the current is reversed, direction of magnetic field get reversed. And one can find out the direction of the magnetic field either by right hand palm rule or right hand thumb rule. Okay, so that's all about the Oersted experiment. Now next topic is magnetic field due to a straight current carrying conductor. Alright, what will be the nature of the magnetic field produced by a current carrying conductor? As we have not studied about the Biot-Savart law, Laplace's law, so we will find out by doing one experiment. So what is the experimental setup? That you first take a cardboard. Alright, you take a cardboard, then at the center of the cardboard make a fine hole. And then you insert the conductor this way, it is perpendicular to the plane of the cardboard. Alright, so look at the diagram, this is the cardboard, as I showed you, this is the cardboard. Then at the center you have made the hole and you have inserted the conductor. Then you see the two ends of the conductor, this is the conductor. Two ends of the conductor is connected to a battery, rheostat, key and ammeter in series. Alright, now here when you will draw this diagram, take care that you see when I have drawn the diagram, then this is the hole, below the hole I have discontinued the line. Alright, what does it mean? When I have discontinued the line, it means that the conductor is perpendicular to the plane of the cardboard. Alright, if you join this one, if you make a continuous line, it means that the conductor is lying on the plane of the cardboard. But when you are discontinuing, it means what? That the conductor is perpendicular to the plane of the cardboard. Alright, then what is done? On the cardboard, a large amount of iron fillings are sprayed. And then you switch on the key is closed. Then you see, according to the battery connection, current will pass in the conductor in the upward direction. Now what you do? You gently tap the cardboard. You just go on tapping the cardboard gently. Then what you will observe? The iron fillings, they will set themselves in concentric circles. What is the center of the circle? Center of the circle is the hole through which the conductor is passing. Alright, now what is happening actually? What are these iron fillings or the concentric circles representing? They are representing the magnetic field lines. Alright, so what is the first information, first observation? That magnetic field lines are situated on the plane of the cardboard. And how the plane of the cardboard is? Plane of the cardboard is perpendicular to the plane of the conductor. So, the first point, first observation, not observation, sorry, conclusion. First conclusion, what you must note down. I am saying it slowly. Please write it down. The first conclusion, you must write, learn and remember. And remember it till your board exam. That when a current passes through the straight conductor, magnetic field is produced perpendicular to the plane of the conductor. You see, this is the plane of the conductor, and where is the magnetic field? On the horizontal plane. So, this is the first point, an important point you have to remember. Where the magnetic field is produced? Magnetic field is produced perpendicular to the plane of the conductor. Okay? Then, second observation. If you increase the current by using the rheostat, you can observe it from the reading of the ammeter. You will see that number of concentric circle, it increases. Not only that, it extends till the longer distance. Alright, what does it mean? If you increase the amount of current passing through the conductor, the strength of the magnetic field increases. Okay, so what is the second point? You have to write and remember. I am saying slowly, please write down. Magnetic field strength depends on the current passing through the conductor. Okay, magnetic field depends, magnitude of the magnetic field depends on the current passing through the conductor. Then you have to write, if current increases, magnetic field increases and vice versa. Is that clear? Third point. Third observation, you just see, near the conductor, the concentric circles are denser. Whereas when you are going away from the conductor, the density of the circles decreases. What does it mean? Magnetic field strength increases near the conductor. Magnetic field is stronger near the conductor and magnetic field decreases with the distance from the conductor. Alright, so what are the 3 points I said? These are the important points you are supposed to learn and remember for your board exam. So I am repeating that magnetic field is produced perpendicular to the plane of the current carrying conductor. Secondly, if the current through the conductor increases, magnetic field increases, vice versa. Then third point, magnetic field is stronger near the conductor. A magnetic field decreases with the distance from the conductor. Is that clear? So these are the important points you have to remember. Then the last observation and last point related with this one. By the battery means if you just change the polarity of the battery, you connect it in the positive terminal and negative terminal here. Then you see the current will be in the downward direction. Alright, now here when the current is in the upward direction, what is the direction of the magnetic field? Use the right hand thumb rule. You see the right hand thumb rule, the 4 fingers, it is coming in the anti-clockwise direction. So you give the arrows in the anti-clockwise direction. So you see what you are getting, the direction of the arrows if you give, it is looking like this. Okay, so another important thing you are observing, just you see, if you consider the direction of the magnetic field here, it is in the inward direction. Just you see, if I set my right hand thumb, it is in the inward direction. But when you are considering the direction of the magnetic field this side, left side, then how I will place my finger here like this, then you see what is the direction of the magnetic field? It is in the outward direction, because if it is anti-clockwise, then you see here it will be inward, this side direction will be inward and this side direction will be outward. Alright, this is the point you have to remember. And if you change the direction of the current, then you see, you will place your hand like this, the thumb in the direction of the current and hold the current carrying conductor like this. Then in which direction the forefinger is? In the clockwise direction. So in that case, what will be the direction of the magnetic field in the clockwise direction? Alright, so from this observation, what is the conclusion you can make? If the direction of current in the conductor is reversed, I repeat, if the direction of current in the conductor is reversed, the direction of magnetic field also get reversed. Alright, so 4 points I said regarding this magnetic field due to a straight current carrying conductor. Please write, learn and remember. Next topic is magnetic field due to a straight current carrying circular loop. So instead of a straight conductor, what you have to do? You have to take a circular loop. So how to set up the experiment? Again, you take the cardboard. Now, instead of making a hole at the center, you make 2 holes near the center. Just you look at the diagram. Instead of making the hole at the center, you make 2 holes near the center. Okay, center the cardboard. Then, through the left hole, you take the conductor up. Alright, through this hole, you have taken the conductor up. Then you turn it in a semicircular loop. Then insert the conductor down through the second hole. Okay, then here you complete the loop. Okay, and at the 2 ends of the loop, connect one battery, rheostat, key and ammeter in series. Alright, so this is the circuit connection. Another point here, again just like the previous experiment, spread iron filings, sufficient amount of iron filings on the cardboard. Alright, so this is experimental setup. Then what you have to do, you close the key. The moment you will close the key, then you see the current will pass through the loop in this direction. You see the current is coming. Here another point you see, here this loop is not continued. Here I discontinued. I have just drawn the upper half. Why? Because as I said already, that loop is taken like this. So the loop is perpendicular to the plane of the cardboard. Just to indicate that, do not draw the complete loop by the solid line. Okay, only the upper portion is visible, the down portion is not visible. The discontinuous line means it is not visible. Why not visible? Because the loop is perpendicular to the cardboard. Okay, now you see here, after that you gently tap the cardboard, then you will observe that iron filings will set themselves along 2 sets of concentric circles. Alright, now the question is why 2 sets of concentric circles? You see, easily you can explain it. If you consider the first hole and if you consider a small portion of the loop, it will appear just like a straight line. Alright, so due to this conductor, you have got 1 set of concentric circles as the magnetic field lines. Then near the second hole, if you consider a small portion of the loop, it will again appear like a straight line, isn't it? So you see, again we are getting another concentric set of circles for this. Now what will be the direction? Let us give the direction by using the right hand thumb rule. Right hand thumb rule, if you use here, this first one, you see the current is in the upward direction. So if you set your 4 fingers, it is coming in the anti-clockwise direction. So give the arrows in the anti-clockwise direction. Alright. So if you give the arrows for all the circle, it looks like this. Now come for the second set of concentric circle. Here you see in this one the current is in the downward direction. So you have to set your thumb in the downward direction and 4 fingers along the conductor. You have to grasp the conductor by the 4 fingers. So if you do this, in which direction it is coming? It is coming in the clockwise direction. So give the direction of current in the clockwise direction for all the circles, second set of circles. And then you see what is the nice thing you are getting. Now observe the arrows within the loop. Observe the direction of the arrows within the loop. You see they are all in the same direction. Okay. And in which direction? Inward direction. This is not upward. It is inward. Why? Because you see this is the conductor. This is the conductor plane of the cardboard and the arrows are like this. Means with respect to the circular loop, it is in the inward direction. Alright. But if you consider the arrows, okay, outside the circular loop, then you see all are in the outward direction. It is not downward. Actually, these are like this, no? If I hold the cardboard are like this and arrows are like this. What does it mean? These are in the outward direction. So here, within the circular loop, in which direction magnetic field is? In the inward direction. But outside the loop, in which direction magnetic field is? In the outward direction. So, first conclusion you have to write is that magnetic field due to the current carrying circular loop is perpendicular to the plane of the loop. You see, this is the plane of the loop, and where the field is either inward direction or outward direction. So, you see, when it is inward, perpendicular to the plane of the loop. When it is outward, then also perpendicular to the plane of the loop. So, in this case also, magnetic field is produced on a plane perpendicular to the plane of the circular loop. Is that clear? This is the first conclusion you have to write, you have to learn, you have to remember till the board exam. Second point, if you will consider the magnetic field lines at the center, this is the center. You see, at the center, the field lines are almost parallel. What does it indicate? At the center, the magnetic field, at the center of the circular loop, magnetic field is uniform and constant. Okay, so what is the second conclusion? Magnetic field is constant at the center of the loop. Okay, next is in which direction the magnetic field is at the center of the loop. Magnetic field is along the axis of the loop perpendicular to the plane of the loop. Just you consider, suppose this is the circular loop. Alright, now you see it may have two axes. You may consider this as the axis. Now this axis is on the plane of the loop. And you may have another axis. This is also axis. Okay, now this axis is perpendicular to the plane of the loop. Now look at the diagram in which direction magnetic field is. If you consider like this, it is along the axis, okay, perpendicular to the plane of the loop. So at the center, what is the direction of the magnetic field? At the center, direction of the magnetic field is along the axis of the loop perpendicular to its plane. I repeat, at the center of the loop, the direction of magnetic field is along the axis of the loop perpendicular to its plane. Clear? The next point. It has been observed that by the rheostat, if you increase the amount of current, then what happens? The concentration of circle increases. The circle becomes denser, which indicates magnetic field increases. And if you decrease the current by the rheostat, then it has been observed that concentration of circle decreases, which indicates that magnetic field decreases. So, this point is very, 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 very important. You have to learn and remember it. That when the magnetic field is produced by a current carrying circular loop, then the point you must note down this way, that strength of the magnetic field depends on the current passing through the loop. If the current passing through the loop increases, then strength of the magnetic field increases and vice versa. Alright, then next point, here you see I have taken only one turn. Instead of one turn, you can take several turns of the loop. And then ultimately at the two end, you join the battery, rheostat, key and ammeter. Then what you will observe, if you increase the number of turns of the loop, then magnetic field strength increases. If you decrease the strength of the number of turns of the loop, then magnetic field decreases. So, the question you may get like this in the exam, that on which factor the magnetic field produced by a current carrying circular loop depends. Then what are the two factors? It depends on the current passing through the conductor and the number of turns of the loop. Okay. If you increase the current passing through the loop, magnetic field increases and vice versa. If you increase the number of turns of the loop, magnetic field increases and vice versa. Alright, and then next point is by the battery if you change the direction of the current. Now, for the circular loop of current, one can use the right hand thumb rule this way. Just you observe it, I am showing it. Suppose that is the circular loop of current. Then you place your 4 fingers along the direction of the current. Then the thumb will give you the direction of the magnetic field. So you see, the moment you are placing your 4 fingers like this, the thumb is in the inward direction. And the inward direction we represent it by a cross. The inward direction we represent it by a cross. Why? Because you know there is we generally represent the direction by a vector. And how the vector looks, the vector is nothing but an arrow. In an arrow, this is the pointed end, and you know at the end of the arrow there is a cross-like structure like this, isn't it? So if the vector is in the inward direction, so you can see the tail of the vector, and the tail of the vector appear like a cross. So, inward direction, this is perpendicularly inward. This is perpendicularly inward. I have written in short, perpendicularly inward. If you write this symbol, it indicates perpendicularly inward. Now you see, if the current is in the opposite direction, means the current is in the anti-clockwise direction. How to find out the magnetic field? Again you use the right hand thumb rule. Again, how to use the right hand thumb rule here? 4 fingers along the direction of the current. Thumb is, you see, thumb is in which direction? Outward direction. Alright, so outward direction, you can see the tip of the arrow. So the tip of the arrow, it looks like this. So we represent it by this one. Okay, means this represent, it is outward direction. What does it represent? It represent perpendicularly outward direction. Okay, the writing part you may not be visible properly, but I am saying verbally, so please note it down. This one represent what? Perpendicularly outward direction, and this cross represent what? Perpendicularly inward direction, and the dot represent perpendicularly outward direction. Just you look at my thumb, you can see the tip of the arrow. This is the arrow. Tip of the arrow, you can see the and tip looks like a point. So it is represent perpendicularly outward direction. So you see, the moment you are changing the direction of current in the loop, the direction of the magnetic field is getting reversed. When it is in the clockwise direction, the current, then magnetic field is inward. When the current is anti-clockwise direction, the magnetic field is outward. This thing never try to mug up. Use the right hand thumb rule. Okay, automatically you will get it. So, from this one, the last conclusion you can make regarding the nature of the magnetic field produced by a current carrying circular loop, that is that magnetic field, if the direction of current in the loop is reversed, the direction of magnetic field get reversed. Alright, so I am summarizing all the points together. First point, the direction of the magnetic field is perpendicular to the plane of the circular loop. Second point, at the center of the loop, magnetic field is constant. Third point, magnetic field acts along the axis perpendicular to the plane of the loop at the center of the loop. Then next point, magnetic field depends on the strength of the current. If the current increases, magnetic field increases, vice versa. Next point, magnetic field depends on number of turns of the loop. If the number of turns increases, magnetic field increases, and vice versa. Then last point, if the direction of current in the loop gets reversed, then direction of magnetic field also get reversed. So these are all the important points you are supposed to learn, write and remember. Thank you girls.